impedance. In Arabic it's called ممانعة أو معاوقة. It is a general term for resistance. Actually, impedance for any resistor is the same resistance, R value. Now we have different electrical components. Those components are resistance, or resistor if you wish, inductor, and capacitor. For each one of them there is a way to calculate the impedance. For resistor, the impedance is the same as R. For inductance, Z for the inductance is an imaginary part. It is J times omega times L, where omega is the radiant frequency. Omega is 2 by F, and L is the inductance. On the other hand side, we have the impedance for a capacitor, which is minus J over omega C. The same thing applies to omega here. It's 2 by F, and C is the capacitance. Now, in order to calculate impedance for different components, it depends on whether those components are connected in series or parallel. This is a simple example where we have resistor, inductor, and capacitor, and the values are given as follows. Let's say this is 2 Henry, 4 ohm, and for example 2 farad. Now, to get the overall impedance for a series connected components, we add them together. Starting by the real part, the only real part is this one. It doesn't have J here, so this is 4 ohm plus. Now the imaginary part, there are two parts. One of them is positive, the other one is negative. The positive one is the inductor, which is J omega L minus J over omega C. Now we can take this J common, and omega must be given to us, or the frequency must be given to us. For example, let's assume that omega is given as 10 radian per second. If omega is 10, then omega L is 20 minus 1 over 20. Now this 20 is omega C. Okay, so this is the total impedance for series connected. If they are parallel connected, then you apply the following formula for any parallel connection. Z for any parallel connection is their multiplication. You multiply two impedances by each other, then you add them together. Okay, thank you.